Alright, today we're going to talk about Ohm's law. We're going to do a little review of what we talked about yesterday. A couple vocab words that we covered. Voltage, which is the push of the electrons. It's kind of the work that they're doing. Current, which is the actual flow or the movement of the electrons in the given circuit. And the resistance, which is where the work is done. It's what slows and kind of hinders the movement of the electron. We'll go over the units again real quick. The units for for the voltage that you're going to determine is volts. The resistance is ohms, and current is amperes or amps. This right here is what the resistor is going to look like when we put it in a circuit. We'll see that in a minute. This is just a little humor. Join the resistance, you got a resistor. And another one, this is the omega is the shorthand for ohms. And it says, he's talking to the resistor, said, come meditate with me, man. You don't have to resist everything. Alright, this is a simple circuit. You have your battery here. This is where your voltage comes from. It's going to flow through the wire to the light bulb, which is acting as the resistor in this circuit. So you're right here. You're an electron. You're going through the battery. You're working your way up to the resistor. You get here. That's where you do your work, because that's where it's trying to hinder you. You're in the resistor. So you get tired. You come around. Get back to the battery. You're energized again. On the slide, I put think about the Energizer Buddy. You keep going and going. So you're just going in the closed loop. When you get to the battery, you get recharged again. You go back through. Alright, what we're going to do is we're going to come up with our own kind of relationship between voltage, current, and resistance. And in order to do that, we're going to use a simulation right here. The V equals IR, you see right there, that's the relationship of Ohm's law. Voltage equals current times resistance. So what this allows you to do is play around with a couple of numbers, and it'll change the circuit and the coefficients right there in order to kind of form your own relationship between the variables. Can I get a volunteer to come up here and work this? Anyone? Alright, you're up. Alright, so what we want to do is we want to figure out a way to maximize the current in this circuit. How would you go about doing that?
To maximize current, would you want to increase resistance?
Let's try it, see what happens. Okay. And you see go back up. See, the resistance gets higher, so the current gets smaller. Now go back down. The current keeps getting bigger as the resistance goes down. Alright, take another volunteer. Alright.
Done.
Yep, you're done. Thanks. Alright, now let's maximize the voltage. There you go. Okay. As you change the voltage, what happens to the rest of the circuit? Okay, it does. What's that mean? Anyone want to help her out? The current increases as the voltage increases. What's that mean? It means they're related to each other. As one increases, the other increases. As one decreases, the other one's going to decrease.
Sorry, my bad.
No, that's all right. All right. Okay. This is a little helpful tool called Ohm's triangle. When you have a given circuit, you're able to, or you're asked to give, to solve for a given value. This is real helpful because if you're determining the voltage, you cover up the variable that you want to solve for. So if you're determining the voltage, cover up the V, and you get I times R. See that? And then if you're solving for current, which is the I, cover that coefficient, and you get V over R. So it's just a helpful little way to establish a relationship between these variables. This is just a simple practice problem. If you remember the Ohm's law equation is V equals IR. If we are trying to determine the current through this simple circuit, what formula would we use? What variation of the formula? Would you want? I can go back to the triangle. We're trying to solve for the current. You want me to go back?
There you go.
All right, we're solving for the current. So what do we want to do? Okay, so what's our?
V divided by R.
Okay, so we'll go back. So if our voltage is 10 coming from the batteries, what's our resistance?
2.
No, the resistance,
5.
which is R. 5 ohms. Okay? So if you're solving for the current, you would do 10 divided by 5, which is 2. All right. Great. That's the current through this circuit. All right. Now everyone take out your phone. We're going to do a little assessment before the bell rings. Alright, I don't know if anyone has ever used this, but this number right here, 22333, is the number you want to send a message to. Anybody does have a phone, I have mine. So you want to send your text to 22333. And then question states, what is the current setup for determining the current through a circuit? Can you guys read that? And just text in the number to the answer that you think it is. Yep. When it says text code, that's these numbers right here. Yeah, this number. Alright, so the correct answer is I equals V over R. Those of you who put I equals R over V, that's probably just mixed up in your thing. You didn't. I could have put up the triangle and then made it easier, but wait one more. This question pertains to a circuit similar to the one we just did. If you have a battery, let's say battery, with 10 volts, and you're lighting a light with a resistance of 5 ohms through a filament, what is the current through the given filament? The number's still the same, you just text your code here. That's correct. Can anybody tell me why that's the correct answer?
10.5.
Alright. And that's all for today.